Let us have a look on the calibration verification algorithms. The through-mesh reflect-reflect calibration method developed by MPI uses the data redundancy. So actually, what does that mean? We acquire more data that actually needed to compute error terms. And based on this information redundancy, we can already have a look on some very specific characteristics of calibration standards and make a decision if our calibration results are consistent or not. We call it a self-verification algorithm. Even before computing the error terms, Calibria already knows if calibration will be successful or not. We don't need to measure any other reference elements to understand that the calibration will fail or the calibration will be acceptable. So we recently check for the consistency of the data, the verification algorithms that look into the repeatability of the data, as well as they analyze the raw data, consistency of the data. And the next verification step is the self-verification algorithms, which are looking into the correct data of reflect elements like open and short during the calibration process. Let us see how this is all executed. We just trigger the calibration process, and I will walk you through exactly step by step what is going on behind the scene. Calibria moved the check to the through standard. At first, we looked at the repeatability data. So repeatability is checked for the very tight, short frequency range with a few data points. So it goes very, very quick. And after repeatability is verified, we look into the raw data consistency. So that is everything seems to be good. So the quality of the data marked like green on the through standard. Exactly the same algorithm happened on the load standard. Now we moved to the open calibration standard. We acquired the data for the open. And behind the scene, Calibria will look not only on the repeatability and analyze the raw data of the open, we also look into the self-verification algorithm already. Measuring by the open standard, we know that calibration will be successful and calibration will not be successful. Now we measure the very last calibration standard, which is the short, and the calibration algorithm was completed successfully, and error terms were computed and pushed to the network analyzer memory. What you see, the result is on the widget of the calibration procedure, so it's the MRR calibration, so that the verification of the calibration quality verification, so self-verification feature turned to the green. What does it mean? That means that the results of the consistency verification algorithm, which we execute on the open standard and on the short standard, were within the boundaries set up originally by an expert. Means that the calibration is consistent and we can rely on the calibration results and move measuring our devices under test.